Good afternoon, my dear students. How are you? All are fine? Yes. Okay. Today you are discussing about what are the importance of chemistry. Our lesson, importance of chemistry. Chemistry play an important role to improve the quality of life. Chemistry produces many compounds such as fertilizer and insecticide. We build a better and strong building, different weather conditions with modern cement, concrete mixture and better quality steel and also fabrics, etc. We are preparing. Chemistry is everywhere in our world around us. Our body is made up of also chemicals. Continuous biochemicals reaction occurring in our body. In the chemistry industries, manufacture and useful materials that are used in our everyday life. For example, polymers, dyes, alloys, etc. As chemistry play an important role in our day-to-day life. So, without chemistry, there is no anything. So, we should learn chemistry day-to-day our life. Our unit lesson, name of the lesson is Unit 1, a basic concept of chemistry and chemical calculation. The basic concept of chemistry and chemical calculation. Here, what is the learning objectives? The learning objectives classify different substances into element, compounds and mixture. Classify different substances into element, compound and mixture. And also to define the atomic mass and molecular mass. These are the two learning objectives for today's class. What is the element? All of you know it is only one type of an atom. That is element. What is compound? Two or more elements combines to form compound. And what is a mixture? Two or more combines to form mixture. Two or more compounds combines to form mixture. We can discuss one by one. We can start with classifications of matter. Classifications of matter. Classifications of matter. Matter can be classified into physical classification and chemical classification. Matter can be classified into two types. How much types? Two types. One is physical classification. Physical classification. Second one, chemical classification. Chemical classification. Here the physical classification, all of you know that there are three types. What are they? Solid, liquid and gas. What are they? Solid, liquid and gas. Can you say what is the examples of solid? Okay, ice. Examples of liquid? Water. Examples of gas? Water vapor. So, matter can be classified into two types. One is physical classification. Number two, chemical classification. The physical classification again classified into three types. One is solid, liquid and gas. Solid example, ice, liquid, water and gas, water vapor. Next about the chemical classification. First one is mixture and next one is a pure substance. Mixture. Second one is pure substance. What is mixture? It is only one type of an atom. Okay, what is only one type of an atom? Mixture. Mixture can be classified into two types. This mixture can be classified into two types: homogeneous and heterogeneous. Homogeneous. Second one is heterogeneous. What are the two types? Homogeneous and heterogeneous. Here the homogeneous can be same. It is the same phase. For example, salt in water, same phase. Salt in water. Green tea. These are the examples of homogeneous. Heterogeneous, oil in water, different phase. Here, both are liquids, oil and oil in water, both are liquids, but they are in different phase. Next one, the pure substance can be classified into two types. The pure substance here, the pure substance can be classified into two types. What are they? Mixture, pure substance, element and compound. Element and compound. What is an element? Element consists of only one type of an atom. This is an element. For example, can you see one element? Copper, Cu, copper, gold, Au, silver, Ag. These are all elements. What about the compound? We can be used. Compound means, what is a compound? Two or more element combines to form compound. Two or more element combines to form compound. And one of the examples is copper sulfate. What is the formula for copper sulfate? CuSO4. CuSO4. Copper sulfate is a very good example for the compound. Here, copper one element. Copper metal is Cu, one element. Sulfur also one element, and oxygen also one element. They are compound. Then two or more element combines to form compound. Okay. Here, the important question for the 2 mark question. Classifications of matter. This matter can be classified into two types. One is physical classification, another one is a chemical classification. The physical classification again broadly classified into three types: solid, liquid, gas. Solid, liquid, gas. What is the examples of solid? Ice. What are the examples of liquid? Water, and gas, water vapor. Here next one is a chemical classification, mixture and the pure substance. They are classified into mixture and the pure substance. Mixture is again classified into two types: homogeneous and heterogeneous. Homogeneous means it is same phase. Heterogeneous means a different phase. Examples for homogeneous is salt in water. Heterogeneous example, oil in water. Here the pure substance again classified into two types. One is an element and another one is the compound. Already I told you about that. An element consists of only one type of an atom. Only one type, for example, copper, gold, silver, etc. And the compound having two or more elements combines to form compound. An example is copper sulfate. The next one is pure substance. Pure substance. Pure substance are composed of simple atoms or molecule. Composed of simple atom or molecules. What are pure substance? Are composed of simple atoms or molecules. They are further classified into elements and compounds. They are further classified into elements and compounds. Next about elements. What are elements? Here, an element consists of only one type of atom. Only one type of an atom. An element consists of only one type of an atom. Here, also know that atom is the smallest electrically neutral particle. What is an atom? It's the smallest electrically neutral particles. Atom is the smallest electrically neutral particles. It is made up of fundamental particles. Made up of fundamental particles. It is made up of fundamental particles. Here, what are fundamental particles? Electron, proton, and neutron. Electron, proton, and neutron. Can you say what is the charge of electron? Negative. What's the charge of proton? Positive. What's the charge of neutron? No charge, otherwise neutral charge. Okay? Element. It is only one type of an atom. Smallest electrically neutral particles. Atom is the smallest electrically neutral particles. All of you know that one. It is made up of fundamental particles. What are they? Electron, proton, and neutron. Electron, the charge of an electron is negative. Charge of the proton is positive. And the charge of the neutron is no charge, neutral charge. Element can exist monoatomic or polyatomic unit. Element. It may be a monoatomic or polyatomic. What is about the monoatomic? It consists of only one element. Maybe copper. Example. Copper. Gold, silver, copper, Cu, one of an element. Gold, Au, that's a single element, exists in single. And silver, Ag, is another example. What about the polyatomic unit? For example, hydrogen, H2. Here having two elements, H2. And also phosphorus, P4, sulfur, S8. More than one element. More than one element we can be say polyatomic, and single element exists is monoatomic. Okay? Have it down. Next, we can start with compound. Previous I told you about the compound. Two or more element combines to form compound. Two or more element combines to form compound. It is made up of molecule which contain two or more atoms in different element. Two or more atom. Two or more atoms two or more atoms of different element. Different element. Examples of compounds. What are the examples of compounds? One is carbon dioxide. What is the formula for carbon dioxide? CO2. In this compound having carbon, one of an element, and oxygen also one of an element. The both two elements combines to form one compound. It is made up of carbon and oxygen. Next, glucose. The formula for glucose is C6H12O6. How much carbon element is there? 6 carbon element. How much hydrogen? 12 hydrogen. How much oxygen? 6 oxygen. So it is also a compound. Next, about the hydrogen sulfide. The formula for hydrogen sulfide is H2S, hydrogen sulfide. This also having two types of element. One is hydrogen and another one is a sulfur. So it is a hydrogen sulfide. Next one is a sodium chloride, NaCl. Which are the element present? Sodium and chlorine. So these are all compounds. These are all compounds. Next, about that, what are the properties of compounds? Properties of compounds. First one, sodium. Sodium is a shiny metal. It's a very, very important formula. One word, sodium. Sodium is a shiny metal. Chlorine is an irritating gas. Chlorine is a irritating gas. Next, once more. Sodium chloride is a crystalline solid, NaCl. Sodium chloride is a crystalline solid. These are the properties of compounds. What is an atom? Atom is the smallest particle of an element that take part in a chemical reaction. But atoms are too small with a diameter of 10 raised to minus 10 meter. Its weight is approximately 10 raised to minus 27 kg. But it is not possible to measure their mass directly. Hence, it is proposed to have a relative scale based on a standard atom. For that, the atomic mass. What is an atomic mass? Carbon 12 atom is considered as a standard by an IUPAC. What is the meaning of IUPAC? International Union of Pure and Applied Chemistry. It is a mass is fixed as a 12 AMU. That is AMU means an atomic mass unit or unified atomic mass. It is defined as 1/12 of a mass of a carbon 12 atom in its ground state. It's a very, very important point. It is defined as 1/12 of a mass of a carbon 12 atom in its ground state. It is a constant, carbon 12 atom in its ground state. One atomic mass, otherwise one unified atomic mass is approximately equal to 1.6005 into 10 raised to minus 27 kg. It is a constant value. In this scale, the relative atomic mass is defined as the ratio of the average atomic mass factor to unified atomic mass unit. It is defined as the ratio of an average atomic mass factor to the unified atomic mass. Have one short formula that we can be discussed. Next, about the atomic masses. Atomic masses. Here It is defined as the ratio of average atomic mass. Ratio of average atomic mass. It is the ratio of average atomic mass factor to the unified atomic mass unit. Just remember the formula for atomic mass, relative atomic mass. The relative atomic mass, the symbol is AR. The relative atomic mass is equal to average mass of an atom divided by unified atomic mass. This is a relative atomic mass, that is AR, relative atomic mass. AR is equal to average mass of an atom divided by unified atomic mass. For an example, relative atomic mass of an hydrogen AR, that is equal to average mass of an hydrogen atom divided by 1.6605 into 10 raised to minus 27 kg. What is 1.6605 into 10 raised to minus 25 kg? It is 1 mu. This is what? 1 mu. AMU. RU. What is 1 mu? 1.6605 into 10 raised to minus 27 kg. Here, hydrogen, the average mass of hydrogen is equal to, what is the average mass of hydrogen? 1.6736 into 10 raised to minus 27 kg divided by 1.6605 into 10 raised to minus 27 kg. Okay, so just we are dividing by this factor to this factor, we get approximately equal to 1.0078. This can be approximately equal to 1.008 U. 1.008 U. What is U? Unified atomic mass. This value you should be learn it. The average mass of a hydrogen atom is equal to 1.6736 into 10 raised to minus 27 kg. Okay, unified atomic mass is equal to 1.6605 into 10 raised to minus 27 kg. Here we get approximate values 1.0078, that is equal to 1.008 U. Next about average atomic mass. Average atomic mass. What is an average atomic mass? It is defined as average of atomic mass of all atoms. Average atomic mass of all the atoms. All the atoms in their natural occurring isotopes, in their naturally occurring isotope. What are isotopes? Same atomic number, different mass number. Here, a very good example is chlorine. The symbol of chlorine is Cl. What is the atomic number of chlorine? 70. Here, chlorine have two isotopes. They are Cl35, 1735 and Cl1737. Chlorine having same atomic number, different mass number. Then here we are saying isotope. This ratio is about 77 and 23 ratio. About 77 and 23. Maybe chlorine 1735 is 77, the ratio is 77. Naturally occurring abundance is 77 and the chlorine 1735 may be 23. Now, what is an average atomic mass of a chlorine? What is an average atomic mass of a chlorine? That is the formula that is equal to 35 into 77 plus, that is 35 into 77 plus 37 into 23. 37 into 23. 23 divided by 100. Divided by 100. So, what is multiplied? 35 into 77 is equal to 2695 plus 37 into 23 is 805 divided by 100. That is equal to approximately equal to 3500 divided by 100. So, we get the 35, approximately 35 U. What is U? Unified atomic mass. What is U? Unified atomic mass. Just it's not an accurate value. Some variation may be having, but you should be right. Whatever may be your calculated answer, you should be right the answer. The next one is molecular mass. Molecular mass. Here the molecular mass. First of all, you should be learn about the relative molecular mass. Relative molecular mass. Relative atomic mass and also relative molecular mass. It is defined as the ratio of mass of a molecule. It is defined as the ratio of the mass of the ratio of the mass of the molecules to the unified atomic mass unit, to the unified atomic mass unit. Unified atomic mass unit. For example, if you are taking hydrogen atom, relative molecular mass of a hydrogen, how can you calculate the relative molecular mass of a hydrogen molecule? That is, hydrogen molecule symbol is H2. Here, how can you calculate the relative molecular mass of hydrogen molecule? That is having one formula that is equal to 2 into, having two molecules, 2 into relative atomic mass of a hydrogen atom. Relative atomic mass of hydrogen atom. That is equal to 2 into, already we learned, 1.008 U. What is U? Unified atomic mass. Okay. That is equal to, when you have multiplied 2 into 1.008, what is your answer? Tell me. 2.016 U. This is the relative molecular mass of a hydrogen atom. And also one more example. What is the relative molecular mass of glucose? Relative molecular mass of glucose. What's the formula? C6H12. 12 O6. For the formula, here you should be count the element. Here having number of elements. Carbon 6 element having, hydrogen 12 and oxygen having 6. You should be multiplied. How much element for hydrogen? Carbon 6. 6 into, what is the molecular mass of carbon? Atomic number is 6. Molecular mass is 12. 6 into 12 plus, and hydrogen, number of hydrogen 12. So 12 into 1.008. 1.008 into oxygen 6 having, 6 into molecular mass 60. So 6 into 12 is equal to 72. Is equal to 72 plus 12 into 1.008 is approximately, its value is 12.096 plus 6 into 60, that is equal to 96. When we are adding these three common factors, we get is approximate value 180 point something 096 unified atomic mass. You should be take 180 CNF, round up 180. This is the relative molecular mass of glucose. Please help me take this one. What is the relative molecular mass of hydrogen and also the relative molecular mass of glucose. Next, about the mole concept. That is the quantity of items as our convenience. We are giving some numbers. The quantity of substance for our convenience. For example, a dozen of rose. How much? Number 12. And also one square paper, that is about 25 sheet. That we are giving one number, that is a mole. How can you explain? To understand the concept of mole, that is used for quantifying atoms and molecules. That is the point. The concept of mole, that is used for quantifying the atoms and molecules in chemistry. Here, mole is the SI unit to represent a specified amount of the substance. What is a mole? It is represent a specific amount of the substance in the SI unit. Correctly, we can be say mole is the SI unit to represent a specific amount of the substance. That is a mole concept. First of all, you should be learn about the definition for mole. 1 mole is the amount of the substance which contain elementary particles, and the atom is in 12 gram of carbon 12 isotope. Can you understand? 1 mole is the amount of the substance which contain the elementary particles as their atom in 12 gram carbon 12 isotope. We are considering 12 gram. That is the 1 mole. Okay? 1 mole is equal to, we are saying Avogadro number. That is what? 6.023 into 10 raised to 23 atoms. My dear children, please take the first volume textbook, page number 6. First volume, chemistry textbook, page number 6. They have a little more calculation. Page number 6, top of the page, calculation of number of entities in 1 mole of the substance, calculation. First volume, first volume, page number 6. Having one calculation. That's the important question. First one is serial number. Serial number. Serial number. Next one, name of the substance. Name of substance. Name of substance. Second one, name of substance taken. Third one, mass of a single atom or molecule. Mass of a single atom or molecule. That's the first one, name of substance. Second one, mass of the substance taken. Next one, mass of the single atom or molecule. Next one, number of atoms or molecule. Number of atoms or molecule. Number of atoms or molecules. First of all, you are taking here number 1, number 2, number 3. These are the number we are giving. Here, serial number 1, we are taking carbon 12. Carbon 12 we are taking. All of you know that one. Name of the substance taken. Name of the substance taken. That is carbon 12. Their molecular mass. Carbon 12. How much? Mass number of carbon. 12. Very good. 12. Next one. This is divided by 6.023. 6.023. Our number 6.023 into 10 raised to 23. This value divided by 6.023 into 23. 6.023 into 10 raised to 23. So what's the value? So as per the textbook, the approximate value is 1.9926. 9926 into 10 raised to 23. If you have 12 divided by 6.023 into 10 to the power 23, we are multiplying, we get 1.9926. This value we get. Second one, glucose. What is the formula? C6H12O6. Here, already we calculate. Here, so molar mass is how much? 180 divided by 6.023 into 10 to the power 23. What's the value? Is approximately equal to 29.89. 29.89 into 10 raised to 23. Is our, as per the textbook value. Some variation may be happen during the calculation time. Some small variation. That is no problem. You should be do as per your calculated value. Not your textbook value. As per your calculated value, do it. First of all, you should be divide 180 divided by 6.023 into 20 raised to 23. We get one value. Then, next one is the potassium dichromate. The formula for potassium dichromate is K2Cr2O7. Say all of you, what is the formula? Potassium dichromate K2Cr2O7. K2Cr2O7. Here molar mass, total molar mass is 294.18. 294.18 divided by 6.023 into 10 raised to 23. So what's the value? 48.851 into 10 raised to 23. If you are dividing this answer by 6.023 into 10 raised to 23, we get this value. Next about potassium permanganate. Potassium permanganate KMNO4. Potassium permanganate. The value is 158.03. Potassium permanganate, its molar mass is equal to 158.03 and divided by 6.023 into 10 raised to 23 we get what's the answer? 24242 into 10 raised to 23. Please all of you do it as your calculator, not our textbook value. This is simply we are taking. You do your whatever may be the answer, you should be do your calculated value. This is a textbook answer. Okay. Anyhow, the third one is, what is the third one? Divide 2 divided by 3. This value divided by this value. Okay. That means 12 divided by 1.9926 into 10 raised to 23. Okay. 12 divided by 1.9926 into 10 raised to 23. What's the answer? That's the question, okay? Third one, that is divide 2 divided by 3. 2 divided by 3, we get 12 divided by 1.9926 into 10 raised to 23. And also 180 divided by 180 divided by 6.023 into 10 raised to 23. And also 294.18 divided by 6.023 into 10 to the power 23. And also 158.03 divided by 6.023 into 10 raised to 23. Can you say what is the answer? All we get 6.023 into 10 raised to 23. That is equal to 6.023 into 10 raised to 23. That is equal to 6.023 into 10 raised to 23. That is equal to 6.023 into 10 raised to 23. Okay. This we are saying 1 mole. These are called 1 mole. The amount of the substance. That is called 1 mole. The amount of the substance. What is about the 1 mole? 1 mole is the amount of the substance of a system which contain many elementary particles as their atom in 12 gram of carbon 12 isotope. What is about the 1 mole? 1 mole is the amount of the substance of a system which contains and many elementary particles as their atoms in 12 gram of carbon 12 isotopes. The elementary particles can be molecule, atoms, ion, electrons or any other specified particles. This is what? 1 mole. Okay, my dear children, we have an assignment. I am giving only a small question for each day assignment. All of you should learn that question. Suppose you are not learning this question means it is very difficult for you when you are studying the last time. We have insufficient time for learning. So, day by day you should be learning small question as per my schedule. You should be write the answer in a note and take one photography and send to my phone. WhatsApp number. I am giving my WhatsApp number. Please, all of you, everyone should be cooperate to me. This is only for our learning purpose. Okay? So you should be write the assignment in a note. Okay? Don't forget. Today assignment is classifications of matter. That's the page number 3. page number 3, top of the page, they have one small classification. Matter can be classified in two types: physical classification, chemical classification. Physical classification example, and chemical classification, what are they? Mixture, homogeneous, heterogeneous, and also pure substance, element, compound. Element example copper, compound example copper sulfate. Am I right? That much. This is a basic concept, or everyone should learn. Okay, and my WhatsApp number 9489340120. If you have any doubt, please contact me. I will help you. Thank you all of you. Thank you. Have a nice day.